This time we are learning new terms, compression and expansion. So far, we've learned translation and reflection. These are all type of transformation of graphs. So if you understand these three, it will be useful to sketch the graph. But like I said, I've already explained about these two. So if you want to know about them, please check out my previous video. So let's get started. To understand compression and expansion easier, I sketched two different graphs, y equal x squared and y equal 2x squared. What's the difference between these two? From the appearance, if you pull up the graph of y equal x squared, you can make the graph of y equal 2x squared. And if you focus on all points, if you pull up all points, you can make the graph of y equal 2x squared. However, how much they are pushed up are different depending on the points. So let's see what kind of change is made specifically. So I focus on vertically y equal x squared and y equal 2x squared. Let's see the value when x equal 1. What y value does each graph has? When x equal 1, y value is going to be 1. When x equal 1, y value of here is 2, because if you plug in 1 here, y value is going to be 2. And let's see the point when x equal 2, I mean here. If you plug in 2 into this graph, y value is going to be 4. If you plug in here, it's going to be 8. And when x equals 3, y value is 9 here and 18 here. So do you find any difference? I fixed all x value. So if you compare these, you can see there's always times 2 here. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. This is called vertical expansion. But why do you need it? Because sometimes math questions ask you, there's a graph of y equal f of x and y equal 2 times f of x. And if the graph of y equal f of x has a point 1, 3, what point y equal 2 times f of x have? In this case, what you can do is, first you can fix the x value. So you can put 1 here, same value as this. And the value here, like I said, y value of y equal 2 times f of x is, you can multiply 2 by the value of y equal f of x. So 3 times 2 is 6, like this. And it's true of all numbers. So if you find the value here a, you can just multiply a here. Then you can find y value here 3a. It's going to be 3a. That's how vertical expansion works. Let me give you another example. I sketched the graph y equal 1 over 2x squared instead of putting y equal 2x squared. What's the difference between these two? Same as the case of y equal 2x squared. If you put down this graph, you can sketch the graph of y equal 1 over 2 square. And if you focus on this, all points are pushed down in this case. And how much they are pushed down are different depending on the points. So again, let's focus on each point depend on fixed y value, so x value. When x equal 1, the y value here is 1. Again, y value here is 1 over 2. When x equal 2, y value is 4. Here, x equal 2. Here, when x equals 3, y value is 9. And here 9 over 2. Now again, let's see the difference. If you might, it's same as the case of y equal 2x squared. There's times 1 over 2 here. If you fix x value, and if you multiply 1 over 2 from the value of y equal x squared, you can find the value here. So again, I give you one question. There's a two graph, y equal f of x, y equal 1 over 2 f of x. And if this graph has the point 2, 2, what point does the graph of y equal 1 over 2 times f of x has? So same as the case of y equal 2x squared, you can fix the y value here. Then x value here. Y value is 1 over 2 times this value. So it's going to be 1. That's how it works. But difference is it's called compression, because to sketch the graph of y equal 1 over 2x squared, you put down. This means you compress the graph. But on the other hand, to make the graph of y equal 2x squared, you pull up the graph this way, then you made it like that. It's called expansion. So there are differences. Okay, then let me conclude it. If there's a value here, in front of f of x, it's going to be vertical expression or compression. Then, depending on the value of a, it can be expansion or compression. If the value of a is bigger than 1, it's going to be expansion. By a factor of a. On the other hand, if the value of a is smaller than 1 and bigger than 0, it's going to be compression by a factor of a. So please remember these two terms, expansion and compression. And this one is important, by a factor a. That's it.